Planet Earth has been storing carbon for billions of years. But in just the past few centuries, people have begun to tap that store, mining significant amounts of carbon in the form of coal to burn in power plants, which now make most of the world's electricity. So far, even the most efficient furnace can only harvest about 35% of that coal's energy. And a lot of the carbon that lay safely in the ground for so long escapes up the smokestack. How much carbon is in the air? We know that carbon made up about 280 parts per million of the atmosphere for most of the past 10,000 years. Since people began using coal to power steam engines in the late 18th century, the carbon count has been inching upward to about 385 parts per million today. But it has been much higher. 500 million years ago, as strange new complex forms of life suddenly burst forth, carbon in the air grew to over 7,000 parts per million. And down through time, the carbon count has fluctuated with the pace of volcanic eruptions, asteroid strikes, plant growth, and ice ages. Around the planet, our energetic industries release each year nearly 8 billion tons of carbon into the skies. Yet only about half that, 4 billion tons per year, stays airborne. Exactly what takes carbon out of the air is a much harder question to answer than what puts it there. Oceans, soils and sands, and plants each scrub the black element from the wind. But which of Earth's natural mechanisms is capturing how much carbon is not accurately known. And each also produces carbon, complicating the calculation. All three of those elements come together in salty tidal marshes, one of Earth's most efficient carbon custodians. But such wetlands are disappearing, appropriated by people for other uses. Offshore, in the oceans, tiny plants begin a separate carbon capture process as they convert sunlight to energy, kickstarting a food chain that ends with the carbon of decaying animals settling out onto the seafloor, where some may become the coal supply of civilizations in the far future. While no scientist yet knows the precise climate-changing effects of storing carbon in the air rather than in the ground, it's clear that year after year, humans are putting much more carbon into circulation than the natural processes are removing. To begin to bring that trend under control, we need to be able to do three things: capture the surplus carbon around the time we're burning fuel, move that carbon to where it can do no harm, and store the carbon securely. And one of the most important jobs that spare carbon might do for us is to force oil deposits together deep underground so that we can pump them up easily. We'll see exactly how to go about doing that in part 2 of Capitalizing on Carbon.